Good morning. I'm Al Pera. I'm with Kimberly Horn. I run their energy services program out of Tampa, Florida. I've been doing this, at least a day or two, I think. Doing commissioning since 1998 when we used to call it making sure the job worked. I've been a CXA since 2008. I am an EMP since I think 2011. I was one of the first 35 to ever get the EMP certification. I sit on the board of the EMA. I'm one of the board members. I've been doing engineering for about 48 years, and I might as well tell everybody now I'm a recovering architect. My original degree was in architecture, but unfortunately I designed ugly functional buildings. So I figured I wouldn't have a career in that, so I did something else for a living. So I'll turn it over to my Gino.
Oh, yeah. So I'm Eugene Solag. I go by Gino. I've been with Onicon, the regional sales manager for Onicon now. Started out right after I got my degree in mechanical engineering. I've been with the company about 7.5, 8 years now. Just been all around North America, putting these flow meters in, seeing all the different installations, and telling everyone about it.
Good morning. My name is Mike Morwin. I am with mechanical testing out of upstate New York. I've been doing test and balance for about 17 years now. About 2015 I got my TBE, and in 2017 I got my CXA. So a little bit of both worlds, and just here to bring some of that knowledge.
Yeah, when we put this together, we thought it would be just kind of interesting to do this as a panel discussion, take it from an engineer's perspective, the rep's perspective, and then the guy who actually has to make it work at the end of the day. While we work on the commissioning side of it, we depend a lot on them, and we work together. So we thought that we would start out with this little thing, and if everybody's figured out, I don't have any other dress code other than black. I don't, So if anybody's seen me for the last 3 days, it looks like I've worn the same clothes. I just only have nothing but black. All right, so everybody sees that this is a thing. It's all right, we're cracking the code. This is the whole idea of why we're here today. Learning objectives, if you really want me to read them to you and you can lull you to sleep, I'll go ahead and do that, but I think you'd really rather hear us talk a little bit. All right, so I always like to start off things with a quote. This one actually my buddy Gino gave me, which I'm going to steal more often now because I like this one. If you cannot measure it, you cannot improve it. That's really a true statement, right? We all, when we in the industry that we are, talking about energy conservation, if you can't save what you don't measure, right? So with flow is the same thing. All right, integration. What is understood that is needed? All right. Everybody here has probably have suffered this problem. The engineers in the room, you look at it, you're supposed to have 10 down, 5 up. So let's put that in plain English. You have a 12-inch diameter pipe. You need 15 pipe diameters. The math is pretty simple. You don't have to go to MIT to figure that one out, that you need 15 feet. Well, I'm working on a plant in Miami that going to the chillers is 24 inches. You think I'm really going to get 30 feet? It's a reality.
Yeah, and exactly. So this is also, the 10 up, 5 down. I hear this a lot from pretty much everywhere. This is kind of only like in a singular situation too. So this is, if you hit the next slide, I think we got the next picture.
For you,
there.
my friend, I will do that.
Yeah, so we have a single 90 with say 9+ diameters out there before that single 90. So that's where the 10 and 5 actually comes from. So, and it all depends on the flow meter technology. We can obviously improve on that, or, kind of have to deal with that 10 up, 5 down. And like he said, on a 24-inch pipe, there's a lot of factors, especially, flow velocity and what's that, upstream obstruction, what's happening before that flow meter. So a lot of the times we kind of like to go out, find the most amount of straight run on either the supply and the return and do an 80-20 split. A lot of the time, probably 75% of our meters don't meet our recommended straight run. And it's hard to get in there, especially with retrofit applications. So an 80-20 rule is kind of the best bet. Find the most amount of straight run and try to do 80% before the meter, 20% downstream of the meter.
So, Mike, what do you actually find when because, think about how I put it, reality, what a concept, right? Because that's what is supposed to happen. What do we really get? This gentleman just explained, you can't get it. But he gave us a thing, but now, so we just kind of interesting, and this is where we thought this was a great slide to put in here. This is where Gino had shown with this model of actually how water flows in a pipe. Right, so it gives you the idea of what he was just talking about, what happens, how the water gets disrupted as it's coming out, going into an elbow, coming out of the elbow, what's going on.
Yes, so that would be like a multiple bends out of plane. One of the worst things upstream of a flow meter, as you can see, it really induces a lot of swirl in the pipe downstream of that. So again, it's kind of control valves, multiple bends in and out of plane. We actually want to be completely away from those things if possible. They just really induce a lot of turbulence in that flow. And what we really need is that, fully formed velocity profile in there, especially with like insertion flow meters or clamp-on flow meters, where, we're taking a snapshot of what that velocity is in the pipe instead of, like the inline type meter where we're actually controlling the area and able to average the flow over the whole cross-sectional area, which helps a lot.
So, Mike, what do you actually find when, I get what I want what I want.
As much as we want.
He tells us what he can do, and what do you actually find when we get out there?
A lot of times they're just placed, in the best position they could be. It's not reality. You're never going to have the straight that you asked for.
Yeah.
And sometimes they're placed in the total wrong spot after the pump, and you're getting a lot of turbulence like you see on screen, and it's just causing bad readings, hard to calibrate against. So never what the ideal situation, I guess you would say.
Yeah. It all depends on the flow meter technology. I mean, you put a smaller insertion meter in there right after multiple bends like that, it's almost a random number generator, and you change the different velocities, it's going to be all over the place. So we really want to stay as far away from these upstream obstructions as possible.
Well, and I think you also, while we're talking about flow meters like you have, but that same thing is required for a Venturi, right? Mm-hmm. And you never.
It's all.
It's actually even worse for a Venturi because that one actually needs that straight length to make it work. Because there is no calibrating a Venturi meter.
Right.
All right. So now we talk about calibration, right? There's different types of calibration. How you're going to do it. In the factory, it's always calibrated, right? It shows up and it says it's perfect. Well, there's a reality to what's not perfect, okay? You put it now you put it in the pipe that doesn't have the right upstream, downstream. Is it still calibrated? So.
Yeah, so it's still calibrated based off velocity, but real world conditions are not lab conditions. So we put it in a pipe, as an example for Onicon, we'll throw it in a pipe like that in our flow lab. We could, it's all calibrate to NIST standards, wet calibrated right there. But you get out in the field, you know what I mean? You have an older pipe from the 50s. Who knows what the pipe wall thickness is there, what kind of buildups on that. That'll affect the velocity and the flow reading. Upstream obstructions, what's come before that. It's really kind of difficult to kind of gauge what you're going to end up with.
Well, what I think is my experience has been when you talk about the age of the pipe. I could tell you it also depends on the type of pipe.
Oh, yeah.
And I don't mean like the physical, whether it's Schedule 80 or Schedule 40. I'm talking about if it's chill water versus condenser water. Condenser water winds up having all which I affectionately call little stalagmites that grow on the inside of the pipe, which now has changed the overall inner diameter of the pipe. So unless you've scanned it, you have no idea what really that inner thickness is, or what your true, if it's supposed to be 12 inches, is it really, is it like 11 and a half? Is it 10?
What's the new ID?
Yeah, what's the new ID? And that's, and that's one thing to look at, So I think it's kind of reality.
Yeah.
What do you find, Mike?
I find items like this on the board here. The design is one item that you really got to look at. Are your components located properly for accurate readings? If I'm out in the field and I need to field calibrate against the flow meter that's there, I want to make sure my gauges are installed across the pump so I can get an accurate head pressure reading plotted on a pump curve. And then I also want to make sure I have triple duty valve, some sort of measuring device out in the system where I can take readings, right? So if I don't have anything there, if I don't have gauges, I don't have a triple duty valve, I don't have any sort of balance valve off that pump, then I'm stuck looking for straight run. I got to bring in the ultrasonic meter, verify that to the flow meter that's installed there, and hopefully things are matching up. So a couple of these pictures up on screen. You got the schematic up top showing the picture. In reality, the picture below it is what was installed. I have gauges after my triple duty valve and before my strainer on the pump. So we're going to get skewed pressure readings there. I try to plot that on a pump curve. It's probably going to make me think I have a lot more flow than I actually do. So in absence of anything there, there's a triple duty valve that had no Pete ports in it, so we weren't able to read anything there. So we ended up having to bring the ultrasonic meter in to help verify against the flow meter that was in there.
All right, then you have accuracy, right? You know, the whole reason we put them in, like think about all the jobs where you wind up putting a flow measuring device, right? Some of it is to whether it is to get the right flow going through a chiller so it doesn't go offline because you've hit laminar flow, because you didn't get the water right. Or you're looking at it, it's the way that somebody for a big central energy plant, which is now sending water out to multiple buildings, right? And now you're reading them back, and that is a form of income. So either you're doing it right or you're cheating somebody, right? No, and I'm not trying to be funny about that, but that's just the reality of that. And so usually, you know, everybody worries about the temperature sensors because those are the first things that go out of calibration. But it's the meter. Is it in the right place? Is it, you get the right distance? So I think, you know, the accuracy becomes a big thing, is understanding it.
Yeah, so in the initial design, kind of like here, you know, initially it's hard on a retrofit type application. That's where it gets a lot difficult. But on the design stages, kind of where he would come in, really trying to, you know, place the meter in a good spot where it has the right straight run. You know, like he said, different applications, whether you're controlling, you're measuring, or you're billing off this flow meter, you know, you could make certain exceptions. So controlling and billing, I'd say, are probably, you know, more critical in that than the measuring side, just to kind of know what's going on in your system. So in the initial stage is really planning, you know, your meter placement and getting that straight run, and planning for that straight run is pretty critical.
And then the accuracy will depend on which type of flow meter you actually use. And look, and regardless of, well, I love Gino, but his technology is not, he doesn't live in a bubble. He's not the only one. So while we might be saying Onacon, but every manufacturer that does insertion meters are very similar. Some are better than others, no question. But the point is the technology is the same for everybody. So
yeah, everyone has the same.
Yeah,
think about the same things. Exactly.
So this here is not based around. I want everybody to understand it. This is not based around one manufacturer. That's why we're here talking about it. So everybody has those kinds of ideas.
Every technology, every meter manufacturer is going through the same exact problems, trying to read an accurate measurement. It's really hard to do. Luckily, water's not as bad as like air is on the air side, because water is not a compressible fluid, so we can kind of, you know, gauge where it's going to be. Whereas putting like a correction factor in there, it's hard to do, because with variable flows and different upstream obstructions, it just acts completely differently. So, like, I mean, and even pipe size comes into play too. So a smaller pipe size is not going to see the same as like a larger pipe size with higher flows.
Well, one of the things, at least one of the projects that I had a lot of existing condenser water pipe. So I've had multiple projects with condenser water pipe where the flows were not accurate, right? And you say, okay, the flows are not accurate. So the first thing, as the commissioning agent, now I took my engineering hat on and I put my commissioning hat on, And I said, okay, I have a Venturi that I could look at. I have flow meters at the chillers that I could look at for this uncondenser water. And I have a pump flows, which should be right. And then I put a strap on to one of them to get another reading. Guess what? All four were different. And not even close. They were just different. So the only thing I could go off of was what the pump said. That's the only thing I could trust, is what the pump said. And that's what we calibrated everything else to. At some point, you got to pick the best devil you're going to have to dance with. Yes?
What's your opinion about using the chiller evaporator, Delta P across that? What's your opinion of using that to estimate?
Actually, Ross, thank you. That was the fifth way we looked at it. We looked at the pump and we looked at the differential because we had from, I think these, I don't remember the manufacturer of the chillers, but we had the data and we looked at it, and once we got within that differential, we, besides what it said, we checked the differential across it, and we said that, and that actually was within reason, within the 10% you would think of what the pump was. And that's what we used everything else to calibrate with. You had another question? Yeah.
I was just a follow-up, because I never see it written on the procedure. You take that flow meter and try to get it calibrated to that. Whereas you always see, at least the specification section says calibrate airflow station at these points. Never seen anything that says calibrate these. So all that we can do is check install location, installation depth, and then the pipe roughness, install material.
Yeah.
We can never go back and say, somebody tried to get the reading as accurate as possible measurement and verification. So is it even possible to adjust those values, or is it pointless?
It's to adjust the calibration factor. I mean, this is specifically for our meters. I'm not sure about other manufacturers. We don't open that up to be able to change that calibration factor, because we throw it in and it's calibrated to a standard, which is NIST in our case. So it's hard to do that. I mean,
Well, I'll answer that part
Yeah.
of it, but how we wind up doing it is you do it with the BMS.
On the back
you
end,
you
yeah.
come back and you put an offset in it, and that's the only way you can do it, but at least, but the problem with that is that you have to keep, is within 3 years, if somebody's not coming back and doing some sort of retro commission or recommissioning, you have no idea how accurate that's remaining.
Yep. And another trick too that we do tell people, so with any insertion type meter, in these difficult locations where there's no straight run and you have this like an insertion meter in there in a retrofit application, you could actually push the meter in and bring it up periodically and almost like traverse the pipe to try and get that average velocity. So you could hook up with a laptop, you could look at what the velocities are, and you could insert it all the way down to the bottom of the pipe, slowly bring it up, find where the average velocity is, and then that's your new insertion depth for that flow meter.
Yeah,
So that's-
regardless of what you told us to put it at.
Yeah. So that's
no,
like,
no. I'm not. I was not sure. I
Yeah, so
was
we-
trying to be funny, but but that's the truth of it, right? Because you go with you think about it.
well, we're basing that off of what straight run that we need. what the
Exactly.
meter
No, I
needs.
get it.
So 75% of the time, it's not in that straight
That's
run
right.
that we want. So
Yes.
that's what we.
Kind of what Al was talking about. I mean, I've had tons of projects where I have different flows at the pump, at the meter, and the meter is installed, per the manufacturer's instructions. And the CAD guy's like, listen, it's calibrated. This is the number. I'm like, well, but the pump curve is showing different, and the differential on the chiller is showing different.
Yeah.
So you're like, well, which one? I go with Al, and I choose the pump usually.
I choose the pump and the chiller because those two should be relatively accurate together.
But at the end of the day, I'm kind of like on eeny, meeny, miny, mo. So, I mean,
Yeah.
Right.
tell me a little bit about, because it is factory.
Right. Yeah.
But why do, I literally never had a job where, the meter installed as per the instructions was actually, didn't need some love in the BMS.
It's kind of like a he says, she says thing. It's our meter's reading velocity, so I mean it sees what it sees. If the meter's set up correctly for the right pipe size, I'm I'm pretty confident at that. And then you could bring in other meter technologies, and if one's still way off in the other one, then I mean, again, he says, she says. But if you get two different flow meter technologies, you throw them in there, like you take a strap on, put it right upstream of that insertion meter or whatever, with the adequate straight run, and if they're plus or minus a couple %, it's hard to argue.
Now, I will say that by and large, my experience has been that on chill water, the flow measuring device is usually relatively accurate. Mike, would you agree with that? Being that it's the condenser water, I think the same would be for hot water. Hot water and chill water, I think what makes one worse than the other has to do with the quality of the water. Think about what's going on with condenser water. It depends, when I first moved to Tampa 46 years ago, the cleaning guys thought the way to fix cooling towers was to put acid in them. Gee, wonder why they didn't last too long. But the point is, that's what the problem was. Chill water's really not been as much of a problem. It's usually the ones that are more affected by dirt in the water and about growth inside the pipe. Mike, you would agree with that?
Sir, yep. Exactly.
All right. So we said, locate, think about when you're about to go open up a restaurant, right? Location, location, location. That's probably the truth of what happens of, do you have enough straight pipe? Where is it supposed to go? And usually all of those are no. We don't have any of what you really wanted. So I actually call Uncle Gino here, and he comes out and goes, put it there.
Yeah.
And then I can go, see, it didn't work. It's his fault. So does anybody have any questions? I think that was kind of like, yeah, we don't want to. And yes.
So if you have a bad install location, because you can't help it, because you gotta move it around out of the shack and then turn it onto the floor, single paddle's not working. Can you improve accuracy by using like a dual paddle sensor, which I think covers more area?
Absolutely, yeah. So that doubles the sensing area between the single and the dual turbine. So it just doubles the sensing area in that. So it does help a lot. So yeah, it's not going to be ideal. And like I said, find the most amount of straight run, whether it's on the supply or the return, and do an 80-20 rule. If it's still, you're still getting some crazy readings, try and traverse the pipe, try and find that sweet spot for your particular application. Yeah, because we're basing ours off of basically that average velocity in that fully formed velocity profile in a pipe. So we're trying to capture that average velocity in there. So we're either like a third of the way down from the top, or a third from the bottom, trying to capture that. But yeah, it's hard sometimes. So.
Yeah, and sometimes you got to think outside the box.
Yep.
So what about types, magnetic flow versus insertion type? I mean,
Yep.
Chill water, hot water. I mean, what is your number one? What have you found to be the most
Accurate?
successful?
Successful?
Yeah.
Inline mags, no question. Inline mags are like us or anyone else. Inline mags are probably some of the best, just because we're controlling that area, right? Any inline meter, actually, really, you control the area that the water is going through. It's usually more powerful. It's got, for a magnetic meter, coils all the way around it. It's, creating a much more even and uniform magnetic field. So it's just really easy to measure the flow in that one and to average the whole pipe.
But even the magnetic insertion type are, in my mind, like, one thing I will tell you here, don't use paddle wheels. Those little turbine ones, yeah, they work for about an hour and a half and then they stop.
It's all based on water quality, yeah.
Yeah, oh no, exactly. I'm joking, but
Yeah.
but they don't work. Yeah.
That's your
Okay.
problem,
Yeah,
right?
put them in a condenser water pipe, and they won't make it out of the week. But I think, when you're doing those, anything, like I said, sometimes you got to think outside the box. Right? Where you talk about you don't have enough distance. I had a project, condenser water. We're using the condenser water, the flow measurement to modulate the valve, so we're getting the right flow going across the chillers, right? You know, think about it, when you have multiple chillers or you're now getting multiple flows because somebody wants to do variable flow on the condenser water. Well, I didn't have any of it was short distances down, so we put them in the long run in between everything, and we did it as a deductive. Yeah, talk about a nightmare, you know. But it works. But you have, again, you have to. I always like to say what Marines have taught me: adapt, overcome, and improvise. And that's what you have to do out in the field. You know, what happens in the lab, so to speak, and that's what I consider when I do design. That's the lab, right? That's the best condition we could get. But then there's reality. As you go out in the field, there's something completely different than what, you know, the mechanical contractor had to add a couple of 3-4 more elbows because there was something that wasn't on the contract documents that I knew about. So you have to overcome it. Mike.
Yeah, what's your opinion, I guess? What flow meter technology you see out there do you trust the most?
Really, I don't see too many. In my area, I haven't seen too many in the field. We were discussing this earlier. Pretty much we see a lot of the strap-on type. So that's kind of what we're verifying against as well. We have a strap-on ultrasonic, so it's a lot easier for us to go apples to apples with that.
Yep.
But yeah, I haven't seen many of the types, the inline mags or any of that yet.
Okay. Cool.
Yes.
I've done this for 55 years. And I've only had one job where the pressure drop on the chiller, pressure differential on the pump, and the flow device all matched up.
Did
And
you
that
buy
was at the
a
Summit
lottery ticket, Chuck, and when that happened? Did you go out and buy a lottery
Yeah,
ticket when that happened?
I should have had. It happened to be at the Summit Park Mall in Niagara Falls, New York. One other situation that came up, and this is where the multiple readings come in, like the sonic meter, often we use that as a tiebreaker. But I had a job at one of the schools in Florida, and the engineer chastised me or our company because the readings didn't jive. Well, wait a minute. My job in the test and balance is to give you the damn readings, and we talk about it. So I got chastised, and I said, well, let's have a meeting at the job site. And they wanted to sit down. I said, no, we're not sitting down. We're going to go test these spots. And they were what I had told them. They said, well, what do you think? And there was no answer at that point, so I said, look, the only thing I can think of is take the pump apart and let's see what impeller you got in the damn thing. And the day after they did that, I got a email or whatever from the school board saying, thank you very much for your putting up with all this. And what they found, and this is the only time, and maybe you're never going to see it, within 1 inch of the impeller was a piece of metal that looked like a hockey stick jammed in the pipe. One time in 55 years. There you go. But that's multiple readings. You got to do it.
Yep, I agree. Anybody else got any questions? Oh, come on, you guys are not going to leave us hanging here. Go ahead, young lady.
Going back a few slides, can you explain the difference between the accuracy on the of rate or full scale?
Gino,
All right.
I'll leave it up to you.
So the different accuracy ratings in every flow meter is going to be different. So every manufacturer is going to have a certain accuracy statement along with their flow meter. So one you might see is a X percentage of full scale. Another one's going to say X percentage of rate, which is that instantaneous accuracy. So what's better than others? We feel that it's a percentage of rate accuracy because that's going to be that instantaneous rate. And a lot of these flow meters that you're going to get or that you're going to see, You know, we're in the HVAC industry here, so we're kind of operating on that lower end, that medium to lower end capability of that flow meter. So accuracy is a pretty big deal. So if you have one that's, say, a percentage of rate, maybe like a DP or something, which is usually percentage of full scale devices with those transducers, you're operating at those lower flows, the accuracy is kind of, it could really kind of get out of control. So a percentage of rate device, anyways, we feel is what we want to use for the HVAC industry.
Well, let's put that in a little bit of perspective.
Yep.
Any of you here do any plumbing? All right, the incoming service to the plumbing, let's say you have a 2-inch service coming into the building. The utility company is going to give you an 1.5-inch meter. Why do they do that? They do that so you get a higher velocity going through the turbine in the meter so it can read accurate. That's why I just want to back you up on that.
Appreciate that.
That's the reality of it. Yes?
Quick question. Vertical or horizontal, what's the preference for mounting the meters?
To install meters, horizontal is great, and then vertical with flow going up is good. Going down, especially with condenser water, open loop water, definitely not recommended to put it on flow going down. But vertical pipe going up, great. Horizontal pipe, great. Yes, sir.
A question, chill water air handling unit, digital flow meter, 1 piece plug near the coil. What is the best way to calibrate that digital flow meter?
I guess it just depends on the type of flow meter technology that's in there. I mean, if it's an inline one, it's hard to do that, especially on the small lines. You could verify it in the field, but
Well, the flow meter's inline. There's 1 piece plug. Would it be best just to add another piece plug on the return pipe?
Well, that's what I was going to, Tim, what I would do if it was me, I would want them on, if I was the engineer that had put the flow meter in, I would have wanted piece plugs on both sides, because now the way you would go to the chiller, right, that the chiller has a pressure drop across it that you can measure, the coil that has the same kind of a pressure drop from the manufacturer, and you can at least assimilate you get to the pressure drop, make sure you get enough water, and then that's the way you would that's the way I would do it. If I was commissioning it, that's the way I would do it. Make sure it's right.
Yeah, this is a retro commission job. So yeah, my thought was the easiest way, just had them freeze the pipe, do a hot tap, throw in a piece plug, and
I would agree.
And then go from there, because they've probably never been calibrated, and they're the unit's 5 years old, and so there's no way to really verify what you're getting. And I don't know what the accuracy is on those digital meters. I mean, how often should you calibrate that? Is that a yearly thing that should be done? 5-year thing? I mean, what's your recommendation? How often should an owner verify his flow rates?
it's kind of a loaded question. It really just depends on the application. I mean, we have people that send them back yearly just to keep that calibration certificate updated. It just really just depends on the application completely. If it's like a really critical measurement, we recommend yearly or every 5 years just to maintain that paperwork, but that's usually for like a billing type scenario. If it's like an inline type, it's kind of hard to do that unless you have a bypass around it to remove that and send it back. But that it's possible, and people do that. So it's just it really just depends on the application. Yep.
Yes, sir.
You guys talk about the difference between calibration and field characterization.
Say that again.
Calibration versus field characterization.
So
Yeah, the difference between a calibration and a field adjustment or field characterization.
So like a field verification versus calibration. So in our world anyways, calibration is against the standard. So basically it comes back to our facility or anyone's facility and test it against a standard that's X times more accurate than the meter. Field verification would be going out there, throwing a meter out there that's comparable and verifying that the flow is in fact what it's saying is.
And if we find that it's not quite accurate for whatever reason, then you have to now go and to the BMS and put an offset so it's reading accurately based on, let's say, like a strap-on ultrasonic flow meter, which will give us another accuracy, or you're using the differential across the chiller or whatever is you're comparing the flow against.
Just curious, going off the existing building stage, if you're doing kind of a forensic study and you're bringing in strap-ons into it, what have y'all found to be the most accurate way to determine
Well,
With the strap on. I think you can take this one.
yeah, and then I have some.
doing detrimental tests? Obviously, we cut through the book, it's great.
But you don't have to cut it. You can if you're concerned about the pipe, and usually it has to do with the age of the pipe, right? Well, let's think about it. You know, once you get above like 12 or 14 inches, usually it is they go from Schedule 40 to standard pipe, right? Which is already thinner than a Schedule 40. And so over time, depending on the velocity, it's going to get worn down. So what you can do is you can actually have the pipes x-rayed. And it will tell you, and you can do periodic x-rays of the pipe I mean, I'm not talking about periodic in a 10-foot, I'm talking about you could do a sampling of so many, because I had that done for an old facility, and we saw that the pipe, that's how I realized they were telling me that they had bought Schedule 40 pipe, and I'm going, you're full of crap, because this pipe is thinner now than standard wall. I said, either you've eaten the pipe away over time that much and you have another problem you got to worry about, or it was standard pipe, which made more sense when I started to look at it. But we can see actual growth in the pipe of where things were growing inside the pipe.
The X-rays will actually show you like the sediment layers.
Yeah, oh yeah, it'll show, like as I affectionately call them, stalagmites. You can see them actually growing in the pipe.
Yeah.
There's also, that's more accurate, but there are also companies that do ultrasonic testing.
Yeah.
Yeah, if you get a thickness, ultrasonic thickness, yeah.
Yeah, you could probably do an ultrasonic ticket, but I found that doing it's a little bit more expensive. But if you're that concerned, I would have to say.
They always say the meter can do it itself, and it's like the ultrasonic, like wall thickness check, and then like the numbers coming out, it's got to be an ID issue.
Right, exactly, and that's usually because there's, again, I've seen so many things happen in my few years that I've done this, right? I had a project where they lost control of the condenser water chemical treatment. They had I forgot what it was, but it was up at like 10,000 for conductivity. Okay, well that's scaling by the second. So when they cut the copper pipe, it literally, the copper pipe, it's let's say it's like an eighth of an inch thick. I had a quarter of an inch thick of white calcium on the inside of the pipe. So everything is it was perfectly round, but it was just like, so they wonder why I wasn't getting enough flow through stuff. So, everything is relative to what's going on that site. There is no panacea, there is no nirvana. It is, everything is dynamic at every different site.
Yeah.
Any other questions? Come on, guys, you can't leave us hanging here. Come on. Yes.
Question for Mike, I guess, kind of what this gentleman said earlier.
Mm-hmm.
Have you ever tried to measure the flow meter that was in an ideal location and got from the engineer and had to change?
Recommend a change in location. Yeah, many times. The one slide, I think it was one forward, is theme of the day is location, right? I've seen them installed strap-ons right off the discharge of the pump, so you're getting all that turbulence there. Reading the pump head pressure is showing you got less flow than the meter's telling you. So definitely recommended a change in location many times out in the field. If it's available, obviously. If it's not, then probably not best to even have the flow meter there at all, really.
Yeah. I would recommend to all the engineers in the room because you usually are not going to get the right location that the manufacturer requests. So that's all as a standard of practice, after all the piping is in, I request that the local rep of the meter come out and give us locations. It's not so much because I don't want to take responsibility for it. I just want it to work right. This is not ego. This is about making the job work right for the client that you've been hired to do the right job for. So I'd rather do it as a collaborative thing. That's Al's opinion of how to take care of it. Yes, sir. And we were worried nobody was going to ask us questions.
I'm at the University of Georgia. We have something like 85 cooling towers throughout all of our properties in Athens. And
Sorry to hear that.
yeah, me too. In order to get evaporation credits from the municipal water provider, they've required us to put in their Neptune water meters. We bought the meters from them. They're the same one that is on my house.
Right, yeah.
Athens.
Yeah.
On the makeup, which is fine, and on the blowdown, which is unusual for that type of meter. So how screwed are we?
Well, those little mechanical meters, the ones that are on all of our houses, the city reads. So that's like, either it could be a percentage of reading if they do calibrate that way. It's probably a percentage of full scale device. On the makeup line, it's probably fine. The blowdown, depending on how much crud is in that line, it's going to jam that meter up for sure. So
Yeah, and it's intermittent flow, not a lot of flow.
yeah, and so it always needs a full pipe. So make sure it's always a full pipe on the blowdown.
They're mounted horizontally, so presumably
Yeah.
it's a full pipe. But
Yeah, so like when we put our flow meters, we either have like a valve downstream of it that doesn't get wide open, so it keeps a little, the pipe full before it, or we put it in a P-trap in the blowdown somewhere.
hypothetically, if they were to allow us to use a different meter, is there a type that would be recommended for that application?
Yeah, so we typically like anything where there's nothing in the flow stream, just because of all the gunk and stuff that could be in there. So like an inline mag meter is nice because there's nothing in the flow stream. It's just a straight through flow tube. We do sometimes like inline ultrasonic meters, maybe a clamp on ultrasonic, unless there's a lot of like buildup or sediment coming through that blowdown. I mean, a transit time ultrasonic might have problems with that too. So anything that's not going to have something in that flow stream that's going to get gunked up and damaged.
Yeah, I would just recommend, see, the problem is that the utility company, it's not that they don't trust you, but they don't trust you, right? So they want to make sure they want to get their money. So that's why they give you the meter. So the only thing that you can do is that you can start looking at your bill, what you're getting a credit in water. If it starts to dramatically change over time, then you may want to have, hey, could you come out and recalibrate this meter or provide a new meter? And sometimes they'll do it. And again, they don't want the trouble from you saying that you're screwing me, because usually that means that you are paying more sewer charge because you're going to be getting less of a water credit back.
Yeah, if there wasn't anything gunk in the water, I mean, it'd be a fine meter for that. But yeah, that's the only concern.
All right, anybody else? There we go.
You had a slide that showed locations you work with. Can you go back to that?
Sure.
The reading of it was so small, I'd like to go through
This one?
that. Yeah, what are I can't read.
Yeah, so like locations to avoid would be control valves, inflowing tees, and then multiple bends in and out of plane. So we want to stay as far away from those upstream obstructions as possible. Straight run, obviously ideal, and then 90s, outflowing tees, pipe expansion reductions are not as bad. Just those four are kind of stay away as far as possible. Cool.
All right. Anybody else?
Well, there's one other one that came up not too long ago, that they had the wrong type of flow device in the chiller plant. They put a Venturi in
Absolutely.
All right. Anybody else have anything? Come on. It's either that or I'm going to have Gino start telling us jokes. No, but I think overall, it's like this is one of the, when we decided we wanted to do this, we thought this was one of those things that there's a lot to this, right? Because there's like almost like a myth to it of what's supposed to happen, right? And so we wanted to. That's why, hence, cracking the code of what it was, what it is, because I think, you know, unfortunately, I'll even pick on my own tribe of engineers, right? They go, well, it says I'm supposed to do this. Well, like, reality is a concept that you don't understand yet, that it's not going to work that way. So I think that that's why we wanted to do this, and that's why we thought, like, Mike's brought great insight, because he's actually in the field trying to test it, to send the dummy me the right, make me happy so he goes away, right? And then we go to Gino and it's like, and go, okay, why didn't your meter work? So it's like, so we're all joined at the hip with this at the end of the day, because realistically the owner is going to look at, they're going to look at me, you know, as everybody knows, proverbial crap falls downhill, right? So if they look at me, so I got to look at him, then I'm going to look at him. So, and I prefer not to do it that way. I prefer that we're all joined at the hip as a team, and we have to make it work. Maybe because I'm a commissioning agent also, that I realize that we're supposed to be, famously in my mind said years ago, a commissioning agent is supposed to be the glue that keeps everybody together, not the acid that tears them apart, right? So when I jumped at the chance to do this, because I thought this was a great idea, because I think there's a lot of misconception, and that's why we wanted to address it.
And the biggest thing, like this gentleman said, is the right flow meter for the right application. So in a constant flow system, the Venturi would work great. You could size it up to always read accurately. But if it gets variable, then it's on the low side, it's going to be hard.
Biggest thing, I'm a commission agent as well, is when we're walking a job, make sure your PTs are where they're supposed to be, because everything we're talking about right now, if you can't measure it, what good is it?
Exactly.
Correct. Yep.
I just recently was talking to somebody about doing hot water recirc, right? And I said, well, it's funny, everybody wants it to work. Every hotel that I've designed, they all want them to work, but the engineers never put any way to measure it on the hot water return. They don't give a spot to actually measure it. And for some reason, they expect the test and balance guy should have had some sense of mind that he was supposed to go do it, even though it's not in the contract documents to do. And that's why I'm not, they were presenters here, that's why I've gone to putting haze valves in. It's a set it, forget it, and every riser gets a certain amount of flow. But the reason I bring that up is because there are so many things that happen in the field that, you're right, if you can't measure it.
Or if it's not on the drone, get an RFI out there.
Oh, yeah.
Yep.
And still, you're not ever going to get a full resolution, but at least you can document it.
Right. I would agree. I would agree.
Now, why don't you tell me about some of the situations at the test lab that we have observed, and sometimes we're like, really? How many meters, needles, everything we've gone through?
Yeah, well, what Chuck's talking about is, I'll probably get banned from the world for this, but in my spare time when I'm not doing anything else between commissioning, teaching, doing other things, I'm also a proctor for the NEB exam. They do a practical for you to get your certification, and there in Largo there's the water wall. And what we've seen there is that two guys with the same meter get two different readings. Then sometimes we have to bring out Billy's meter, which he just calibrated everything before the test. And that comes out different than everybody's, and nothing has really happened. It's this, you know, what is it, 20-foot long wall, 10-foot high, and it's just some 1-inch piping going around with it. There's not a whole lot that's going to happen to this, right? It's a closed loop system. And we see it on a regular basis of where, and it could be a short ridge, it could be an Eleanor. It really doesn't matter what we're seeing. Sometimes we just put gauges on stuff.
When we looked at sometimes the pump curve, it's a standard test rig, but we've seen variations in what the results are. We're going, really? And how many years have we been, I guess I've been doing it for 30, but you've been doing it for at least 20 years?
About 20 years I've been a proctor.
I think it's very upsetting. You know, we have Venturi, we have B&G Circuit Centers, the pressure tabs across the pump, but I know he and I couldn't say how many times, you gotta be kidding me. The only other thing that happens too is if you're using needle valves, sometimes you got the wrong diameter or the wrong length, and you get a wrong reading.
Yeah, because it'll hit the back of the pipe. Because again, it's very small pipe, so it'll hit the back of the pipe, which is now because the water, the pressure is being read in on the bottom. If you jam it down to the bottom of the pipe, so. But the point is that nothing is an exact science. That's I think what Chuck was trying to have me portray is there's nothing in exact science to all of this.
And I think my son here, Brian, you went through that rig and you use the ultrasonic meter, so we know without a doubt what it really is. But Al and I know there's many times we've been shaking our head. You got to be kidding me.
Yeah. So. Well, I guess on that note, since you're going to leave us hanging here and not ask us any more questions now, and the internet destroyed joke telling, by the way. When I grew up as a kid, there was no such thing as the internet, right? I realized there was no such thing as the phone, and we were close. So I don't have to take all those
Electricity.
jokes. There was electricity, yeah. We drew on stone tablets, and I get all that. But really, you learned, as a kid, you learned how to tell a joke. You learned it from somebody, and you got all the inflection and the tone and the thing to make the joke right. Well, today, these young kids don't learn how to tell jokes. They read them, they think they're funny, but they don't learn how to do that inflection to get across or change your voice or whatever. It's like a dying art. And I was just only telling somebody not too long ago when I worked in New York, and I was young, the building I worked in, a lot of people would get on the elevator, and I would get on the elevator last and look at everybody, right? And then I would go, excuse me. I'm working my way through college as a comedian, and I was and all of a sudden some people, you watch someone like, oh yeah, and then everybody is, half the people have a fascination with their shoes at that point. So, but, that's where life is. Cool. Thank you for everybody coming. I hope you got something out of this.